Good morning, students. So starting with the very new topic, that is impression materials, you can expect 1 to 2 or 2 to 3 questions in your competitive exam from this particular topic. These are the contents which we are going to take one by one. Starting with the definition, according to Craig's 12th edition, impression materials are used to register or reproduce the form and the relationship of the oral tissues. According to Richard Van Noot, 2nd edition, impression materials are used to produce a detailed replica of the teeth and the tissues of the oral cavity. What are the ideal properties of an impression material? It should be non-toxic and non-irritant, acceptability to the patients, setting time, the taste and the consistency. Third is the accuracy, both. It includes the surface reproducibility. It should be produce the fine details of the surface. Second is the dimensional stability. It should be dimensionally stable. Fourth is use of the material. It should be easy to mix. It should be adequate working time with the adequate setting time and easy the handling of the property. Handling of the material should be easy. Fifth one is this should be compatible with the model materials. And sixth, last is the economics of material, that is cheap and long shelf life. Coming on to the classification of impression materials. The impression materials should be mucostatic versus mucodisplacive. Mucodisplacive compound includes the high viscosity alginates and the high viscosity elastomers. These record an impression of the mucosa under load. However, the retention of the dentures may be compromised as the soft tissues wish to return to their original position at rest. So, the examples of the mucodisplacive impression material is high viscosity alginates and high viscosity elastomers. Coming on to the mucostatic impression materials, it includes the plaster, zinc oxide eugenol, and with the low viscosity of alginates. Low viscosity alginates are used as a mucostatic and high viscosity alginate is used in mucodisplacive. Materials which are more fluid displaced and the less tissue, these are known as the mucostatic impression materials. They have the better retention of the denture. However, instability of the denture may occur during the functional as the tissue distort. In the mucodisplacive, the tissue come back to the original position, and in this, the tissue distort. Coming on to the impression materials are elastic and non-elastic. In elastic, it includes aqueous hydrocolloids, which includes agar-agar and alginate. Non-aqueous elastomer includes the polysulfides, the silicones, which is further divided into condensation silicon, adhesion silicon, and the polyether. It is the very important chart. It's a very important, you can say, your classification according to your elastic and non-elastic impression materials. So basically there are two types of, as I already have told you, that there are two types of impression materials, non-elastic and elastic. Non-elastic includes plasters, compound impression material, your waxes, zinc oxide, eugenol. Elastics includes aqueous hydrocolloids, which includes agar-agar, that is reversible. It returns to its normal position, and you can say it is reversible to solution to gel or gel form to solution. And second is alginate, it is irreversible. Non-aqueous elastomers, these are of three types: polysulfide, silicones. Silicones are further divided into condensation silicones and adhesion silicones, and third one is the polyether. Classification according to setting reaction: thermoplastic material, agar-agar, and impression compound. These are set by chemical reaction. According to elasticity of the material, the rigid impression material and elastic impression material. Rigid impression material includes impression plasters, impression compounds, zinc oxide, eugenol. Elastic impression material includes hydrocolloids and non-aqueous elastomeric impression materials. According to the type of setting reaction: chelation method, polymerization method, and solution to gel conversions. Chelation method includes zinc oxide eugenol. Polymerization method includes elastomers. Solution to gel conversions includes the colloids. According to the use in dentistry, these are used for the complete denture prosthesis, impression plaster, compound impression, and the paste. Used for the dentureless mouths, alginates impression materials are used, and rubber-based impression materials are used for the dentureless mouth. And for the complete denture, impression plaster, compound impression material, and the paste, two-form paste or liquids are used. Indication of the impression materials: it is used for the diagnostic cast of the fixed partial denture, removable partial denture, in crowns, in inlays and onlays, and it is also used for bite registration. Elastic impression materials: these stretch and bend to a fairly large degree without suffering any deformation. These are used for recording the patient's mouth where undercuts are present. These are used for the partial dentures, overdentures, implants, and crown and bridge work. Basically, these are hydrocolloids and elastomers. Coming on to the elastomeric impression materials. These are viscoelastic. Their physical property may vary with the rate of loading. These are rapidly removed as it decreases permanent deformation, and it increases the tear strength. So you have to take it out immediately from the patient's mouth. Aqueous hydrocolloids. It includes the colloidal suspensions. Chain aligns to form in this. The chains are aligned to form the fibrils. They trap the water in the interstices. Trap the material which imbibes or which traps the water into it. The process is known as imbibition, you can say. So aqueous hydrocolloids, they occur in the two forms: solution and the gel. In solution it is viscous liquid, and in the gel it is elastic solid. They are placed intraorally as solution, which converts into the gel form. And the process of conversion from solution to gel takes place either by thermal or by chemical process. These are semi-permeable membranes having the poor dimensional stability. They evaporate easily, and it causes syneresis. Syneresis means the loss of water. There are two terms. One is syneresis, second is imbibition. Imbibition means water absorption. When a substance absorbs the water, it swells up. And syneresis means they lose the water. When any component or when any material which causes syneresis, it means they lost the water or they shrinks. So syneresis, they contract with time and exudes water. Imbibition, they absorbs water and swells up. I repeat, there are two terms which are basically used in our aqueous hydrocolloids. Number one is syneresis, number second is imbibition. In imbibition, a material when absorbs the water, it gets swells up. The terminology is known as imbibition. And when a material loses the water, tends to shrink, it is known as syneresis. Very important terminologies. Hydrocolloid impression materials. Hydro, as you already know, hydro means water, colloid means gelatin substance. Material used to obtain, these are the material which is used to obtain the preliminary and the final impressions. Again, we have already discussed this classification. Elastic impression compound is divided into aqueous hydrocolloids and non-aqueous elastomers. Aqueous hydrocolloids are two: your agar, which is reversible, alginate, which is irreversible. Non-aqueous elastomers are of three types: polysulfides, silicones, polyether. Silicones can be further divided into condensation silicon and addition silicon. Starting with the irreversible hydrocolloid. So, the example is your alginate. The material, in this, the material that cannot return to a solution state after it becomes a gel. It is known as irreversible hydrocolloid. For example, a material which cannot convert from gel to solution. It is known as irreversible, which cannot be. Irreversible words mean which cannot be reversed. So alginate is the irreversible hydrocolloid most widely used for the preliminary impressions. It is most widely used impression materials. It is used in the study modules. It is removed in the removable or the fixed partial dentures. Examples of the alginate is gel trait dense ply clock, co-alginate GC by GC America. Very important, very important. So basically the composition, this is the composition and the reaction. It is very important. Commonly asked question in your competitive exam. Starting with the composition, it contains sodium alginate. It is the salt of the alginic acid. The salt of the alginic acid, these are extract from the seaweed, that is known as algae. Next composition is calcium sulfate, which acts as a reactor in the reaction. Sodium phosphate, it acts as a retarder. It also contains the filler. It is obtained from the fillers are obtained from diatomaceous earth. It is very important question, and it is even being asked in your AIPG that alginate fillers are derived from. Your answer is diatomaceous earth. Next is the potassium fluoride, which improves the gypsum surface. So basically this is the final reaction which is going to take place to convert a powder into gel or a solution into gel. So basically what happens is sodium phosphate react with the calcium sulfates, leads to the formation of calcium phosphate and sodium sulfate, and it leads to sodium alginate when reacts with the calcium surface with the presence of water. When you mix the sodium alginate with the water, it leads to calcium alginate and sodium sulfate. It is very important. Please keep this in mind. When you mix the sodium alginate and the calcium sulfate in the presence of water, it leads to calcium alginate and sodium sulfate. Next is the physical phases of alginate. The first phase is a solution, or you can say a sol. In the sol phase, the material is usually it is in a liquid or the semi-liquid form. But the second phase is a gel. In the gel phase, the material is semi-solid, similar to gelatin desert. I repeat, in the first stage there are two stages. There are two stages, and you can say there are two phases of the alginate in which the physical or reaction takes place. The first phase is the solution, and in the sol phase the material is generally a liquid or a semi-liquid form. And in the second phase, it is in the material is in the semi-solid or a gel form. Packing and storing of alginate. The containers about the size of a coffee can are the most commonly used form of the packaging. Pre-measured packages are more expensive but save time by eliminating the need for the measurement of the powder. They are already pre-measured packages. Just you have to take it with the help of a scoop and you just mix it out. The shelf life of the alginate is approximately 1 year. It is an important point that the shelf life of the alginate is approximately 1 year. Modified alginates, solution form and in the paste form. In solution form, water but no source of calcium ions. The reactor is the Paris of plaster. In the paste form, it contains alginate solution and the calcium. It acts as a reactor. As you all know, it is the rubber ball and the scoop, the cylindrical, and this is the spatula. Causes for distortion and the dimensional change of the alginate. If an alginate impression is stored in the water or in a very wet paper towel, the alginate will absorb the additional water and expand. This condition is called imbibition. I have already discussed the term imbibition with you, that any substance which absorbs water tends to expand. The terminology is known as imbibition. If an alginate impression remains in an open air, moisture will evaporate from the material, causing it to shrink and distort. This condition is known as syneresis. Syneresis means shrinkage or distortion or the loss of water. Alginate setting. This slide is very important. Each and every line itself acts as an MCQ. So normal set alginate, working time of 2 minutes and a setting time of up to 4.5 minutes after mixing. Fast set alginate, working time 1.5 minutes and a setting time of 1 to 2 minutes. Working time, the time allowed for the mixing the alginate, loading onto the tray and positioning the tray in the patient's mouth. Setting time, the time required for the chemical action to be completed is setting time. A pH change of 11 to 7. Again, important point. A pH of an alginate change of 11 to 7. Altering the setting times of alginate. Cooler water can increase the setting time. Cooler water can increase the setting time if additional time is needed for the procedure. If you want an additional time for the procedure, so what you have to do is you just have to take the cooler water, the cold water into the mix. Warmer water can reduce or shortens the setting time of the procedure. Pre-cool the mixing bowl and the spatula. WP ratio, that is the water to powder ratio. If 15 grams of the powder is mixed with 40 ml of water, gelation will occur in about 3 to 4 minutes at the room temperature. If you are taking 15 grams of powder and it is mixed with the 40 ml of water, the gelation, the reaction is taken place in about 3 to 4 minutes at the room temperature. Please keep this in mind, it is very important. In an adult mandibular impression, generally requires 2 scoops of powder and 2 measures of water. In an adult maxillary impression, it generally requires 3 scoops of the powder and 3 measures of water. So, in adult mandibular impression, you have to take 2 scoops of water, 2 scoops of powder with 2 measures of water, and in the maxillary, simultaneously you have to take 3 scoops of powder and 3 measures of water. Manipulation, very important. Weigh the powder added to the water. Rubber ball can be used. You can use the vacuum mixer also, and the motion of your spatula against the should be in a figure of 8 motion around the walls of the ball. It should be mixed for 45 seconds to 1 minute, and the impression material is then placed or loaded into the tray, and remove the tray from the patient's mouth to 2 to 3 minutes after gelation. This gelation can be seen as the loss of the tackiness. When the tackiness of the impression material loss, it means it is about to set, or your impression material is being set. Overmixing and undermixing. Overmixing, if you did a overmixing, it leads to the reduction in the final strength and reduction in the working time. Same way, undermixing results in the granular mix, or you can say the grainy mix. It leads to the lack of homogeneity, and granular mix will be obtained. So your equipment should be clean, and try to use the dustless alginate. Now what you have to do is, you have to take measured powder with a measured amount of water, mix it in the figure of 8 with the help of the spatula around the walls in the figure of 8. Advantages of alginate: it is inexpensive, it is easy to use, hydrophilic in nature. Hydrophilic means it absorbs water, displaces moisture, blood and fluids, and it can be used in the stock trays. Disadvantages: tears easily, dimensionally unstable, you have to pour it immediately, can be used one time in a single cast, it can lead to thermal changes, low detail production, unacceptable for the fixed prosthesis. It has the high permanent deformation, and it is difficult to disinfect. So before starting with the non-aqueous elastomers, let me tell you some important question which is being asked in your AIPG exams, your PJ and in AIMS exams. About the alginate. So the phenomena of, as I've already told you, the phenomena of the moisture absorption by the alginate impression is known as which techniques? Imbibition. Alginate impression material is less mucostatic than ZOE. Please keep this in mind. It is very important. The important point which I'm telling you right now, these are the MCQs which has already been asked in your previous exam, such as your AIPG exam, your AIMS and PJ exam. So please listen carefully and keep this in mind. These questions are repeat in your coming examinations. So alginate impression material is less mucostatic than zinc oxide eugenol. Solution to gel transformation is seen in hydrocolloids, whether it is your alginate and agar-agar. But your solution conversion of your solution to gel or gel to solution is basically seen in hydrocolloid. This question is asked in your AIMS exam. The setting time of the irreversible hydrocolloid can be decreased by, how can you decrease the setting time? By, as I've already told you, that by raising the temperature of water you can reduce the setting time. It is already being asked in your AIPG exam. So the best way to remove a hydrocolloid impression from the patient's mouth is, the answer is the sudden jerking of the impression material to prevent the tearing. It is asked in this question is asked both in your AIMS exam and in your AIPG exam. So the best method to remove a hydrocolloid is you have to give a sudden jerk while removing the impression material from the patient's mouth. So what all trays are used for the alginate? As you all know, the perforated trays are used for the alginate impression material. It is asked in your AIPG exam. So sodium phosphate is act as a retarder in the alginate. Please keep this in mind. This question is being asked in your AIMS and in your PJ exam, that trisodium phosphate in alginate, it act as a retarder. Imbibition and syneresis is only takes place in your hydrocolloids. So alginates are made dust free by adding what? So your answer is glycol. Glycol is being added in your alginate to make it dust free. I repeat, alginates are made dust free by adding glycol. This question is being asked in your AIPG exam. Impression material which has the high incidence of air porosity. So your alginate impression material is having the highest amount of air porosity, highest incidence of air porosity in alginate impression material. So alginate fillers derived from, as I've already told you in the composition, that filler particles are obtained from or are derived from diatomaceous earth. Minimum thickness of the impression, next is the minimum thickness of the alginate impression materials should be 3 mm. So your minimum thickness of the impression material should be of 3 mm. These all are the important points which is being asked in AIPG, PGI and AIMS examination. So please keep this in mind. It is very important for your exam point of view. Coming on to the non-aqueous elastomers. These are synthetic rubber, large polymers, viscosity classes. It includes high, medium, high putty, monophasic, etc. So consistencies. Polysulfide, it comes with the low consistency, medium and high. Addition silicone comes with the low, medium, high, extra low, monophase, putty or extra high. Condensation comes with the low consistency and putty consistency. Polyethers comes with the medium, low and high. Coming on to the mixing systems. Hand mixings, all elastomers and putty impression materials. Auto mixing system, it includes adhesion silicones and polyethers. Dynamic mechanical mixers, which require a mixer to mix the paste, or you can see impression materials. The examples are adhesion silicone and polyether. Now impression techniques. Simultaneous dual viscosity technique. It consists of a syringe or tray. Single viscosity or monophase technique. It includes adhesion silicones and polyether. Medium viscosity includes the syringe. Medium viscosity includes the trays. Putty wash technique or the wash technique. it includes in the condensation silicons. I guess you all have thoroughly go through it till now, because this is the third time when I am putting this chart in my slide, because this is the very important slide. Just by seeing this, you can easily differentiate and you can easily classify the elastic impression material into aqueous, non-aqueous. Aqueous includes agar and alginate, non-aqueous polysulfide, silicon, polyether. I guess it should be in your tips now. Starting with the polysulfide. So first, it is the first dental elastomers. Indication is it is used in the complete denture, it is used in the removable fixed partial denture, it is used in the crown and the bridge. Example of the polysulfide is Permelastic by the Kerr Company, Omniflex by GC America. Composition. It includes polysulfide polymers, fillers, plasticizers. It has a base and a catalyst. Base includes polysulfide polymers, fillers, plasticizers. Catalyst includes lead dioxide or copper or brown in color. It includes fillers, retarders which consist of oleic and stearic acid. It includes plasticizer, and the byproduct is water. This is the reaction taken place. Mercaptan with the lead dioxide leads to the formation of polysulfide rubber, lead oxide and water. Coming on to the manipulation, it is adhesive to tray. It is uniform, forms a uniform layer, and custom trays are used to load the impression. Equal length of the paste, these are the two pastes, equal length of the paste is used. See, this is brown in color, this is white in color. When you mix it thoroughly, it comes out around this color. Mix thoroughly within 1 minute. Setting time is 8 to 12 minutes. Pour within 1 hour. You have to pour the cast within 1 hour. Advantages: lower the cost compared to the silicon and the polyethers. It has the long working time. It has the high tear strength. It has the high flexibility, and it is capable of producing a good details. So it is a good detail. It has a good detail reproduction. Disadvantages: it has the poor dimensional stability. And as you all know, the byproduct is water, and the cast should be poured within 1 hour. And the cast will be a single. You have to pour a cast in a single go. Custom trays are used. It is messy. The paste and paste mix. It has the bad odor. It may stain the clothing. It has the long setting time. So coming on to the next impression material, let me tell you some important MCQs which is being asked previously in your AIPG and your AIMS examination. So the important MCQs of the polysulfides. Tear strength of the impression material is highest. The polysulfides has the highest tear strength. I repeat, polysulfide impression materials have the highest tear strength. Polysulfide materials is not recommended in your daily practice or in your routine practice. Due to why? Because of unpleasant odor and taste. I have already mentioned here. Due to its bad odor and it also stains the cloth, it can be used routinely, very rarely, not in a daily routine practice. So the disadvantages of the polysulfide materials, as already told you, is stretching. It has the poor dimensional stability and it leads to distortion. These questions is asked as an MCQs in your previous examination. The disadvantages of the polysulfide is has the poor dimensional stability. It leads to distortion. So it is the only elastomer. The polysulfide is the only elastomer which is having the longest curing time. So these all are the various MCQs from the polysulfide which is being asked in your previous examination. So this is the chart which is coming. I'm putting it in the for the fourth time in this, as you can revise it after each and every impression material. Excuse me. Coming on to the condensation silicon. So starting with the indications, complete dentures. It is used in the complete dentures, crown and bridge. Examples of the condensation silicon is Speedex, Colitine and Waldent, Waldent, Primasil by Disdental. Now coming on to the composition, it has a base and a catalyst similarly as that of the polysulfide and a byproduct. Base is the polydimethyl silicoxane and tetraethyl orthosilicate and the filler material, filler particle. Catalyst consists of metal organic ester, that is stannous octate. Byproduct is ethyl alcohol. In polysulfide, your byproduct was water, and in this your condensation silicon, the byproduct is ethyl alcohol. This is the reaction taken place between the ethanol and silicon. Coming on to the manipulation, it consists of two paste and paste, and paste and the liquid. So whatever you are taking, either you are taking paste and paste form and you are taking paste and liquid, you have to mix the both thoroughly. Putty wash technique, it reduces the effect of polymerization shrinkage. The stock trays can be used to load the impression material. Place the putty material. A thin plastic sheets act as a spacer. You can take the preliminary impression and inject the wash material. Advantages: it has the better elastic properties. It is clean and pleasant. Stock trays can be used for the impression materials. Putty wash, it has the good working and the setting time. Coming on to the disadvantages, it has the poor dimension stability as it leads to distortion as that of polysulfide. It has the high shrinkage, leads to polymerization and evaporation of ethanol. You have to pour the cast immediately within 30 minutes. In polysulfide, pour immediately but within the range of 1 hour, but in this you have to pour the cast within 30 minutes. These are hydrophobic, poor wettability, hydrophobic and hydrophilic. That was hydrophilic. Hydrophilic means which absorbs the water. Hydrophobic means which shrinks, which lost the water. So before coming on to the next topic, I have some important MCQs on the condensation silicons. So the first MCQ is, it is already being asked. Immediate pouring of the impression is most critical in condensation silicon. You have to pour the cast impression immediately. So the condensation silicon has the linear contraction of the elastomeric impression materials with the passage of time. So basically the condensation silicon has the highest linear contraction of the impression material. So coming on to the additional silicons, it is also known as vinyl polysilicoxane. It is used in the crown and the bridge. It is used in the denture. It is used in the bite registration, and the examples of adhesion silicons are extrude by the Kerr, express by 3M-SP, Aqueous by dense ply Kolk, Gene by Sultan Chemist, Virtual by Ivoclar Vivadent. Composition. Improvement over the condensation silicons. There is no byproduct. Your polysulfide having the byproduct and your condensation silicon is also having the byproduct, but in your additional silicon it does not contain any byproduct. It is very important. So it consists of two paste system. First paste consists of a vinyl polydimethyl silicoxane, that is pre-polymer. Second paste consists of silicoxane pre-polymer, and it consists of a catalyst which contains chloroplatinic acid. Consists of chloroplatinic acid. This is the reaction taking place. Chloroplatinic acid catalyst act as a. Coming on to the manipulation, it is adhesive to tray as that of condensation silicon, as that of polysulfides. Double mix. Custom trays are used to take the impression. Heavy body elastic material are used. Light body for the preparation. Putty wash impression materials and stock trays are used for the putty impression materials. Advantages. It is highly accurate. It is highly dimensionally stable. See, that was the dimensional stability of the polysulfide and the condensation silicon is poor. It's the poor dimensional stability which causes your distortion, but it is highly accurate. Adhesion silicon, it is far better than condensation polysulfide. It has the highly accurate, high dimensional stability. You can pour it up to 1 week, not within. It is not necessary that you have to pour the cast within 1 hour as that of polysulfide. You don't have to pour the cast within 30 minutes as that of your condensation silicon. You can pour the cast up to 1 week. Very important. The stock or the custom trays are used to take the impression. You can pour the multiple cast, not even a single cast. You can pour the multiple cast from a single impression material, and it is easy to mix and the pleasant odor. Coming on to the disadvantages, it is expensive. Though it has a very good advantages, but it has some disadvantages, which is it is quite expensive. The sulfur inhibits the set, so latex gloves you have to use. Short working time. If you are using the latex gloves, I'll tell you this point later. It is asked as an MCQ. It has the short working time. It has the lower tear strength. Possible hydrogen gas release. Bubbles on dye and palladium added to absorb. So before coming to the next, your polyether, I would like to tell you some MCQs which is being asked regarding the adhesion silicon. So this is the impression material. The adhesion silicon is the impression material which has the least dimensional change upon disinfection. When you disinfect, it leads to least dimensional changes. So palladium is added to polyvinyl silicoxane. The palladium, what is the function of palladium? It acts as a scavenger. So palladium is added to your adhesion silicons. It acts as a scavenger. Most ideally elastic. It is the most ideal elastic impression material. So putty consistency of adhesion silicon is mixed by kneading. See, if you mix this addition silicones with the help of latex gloves, it inhibits the sets. The sulfur in that inhibits the set. So the best method is you manipulate, or the kneading of the addition silicone is done with the fingers without the gloves. Very important. Even ask question in your AIMS exam. So surfactant in this, the surfactant, it decreases the contact angle. In addition silicone, the surfactants are added. Why the surfactants are added? These are added to reduce the contact angle and improve the castability and wettability. It is your contact angle. When you add the surfactant, it decreases the contact angle. It is a commonly asked question in AIMS and AIPG exam. Coming on to the last but not the least on your non-aqueous elastomers are the polyether. So starting with the indication part, it is used in the crown and the bridge. It is also used as a bite registration. Examples of polyether is Impregnum F, that is by the company of 3M SP, Permagen by the 3M SP, Pentamix by 3M, P2 by Herosis Culture, Polygel by Dents by Cork. Composition: it consists of a base, catalyst and cationic polymerization. So base consists of, it is a difunctional epimine terminated prepolymer. It contains fillers, it contains plasticizers. In a catalyst tube, it contains aromatic sulfonic acid ester and the fillers. So cationic polymerization takes place, the ring opening and the chain extension. So there is a ring opening and the chain. This is the ring opening and the chain extension. So ring opening, it itself acts as an MCQ. In which reaction of the non-elastopolymer polymer impression material the ring opening method is seen? So your answer will be polyether impression material. Coming on to the manipulation, it is adhesive to tray. Stock or the custom trays are used. It is very stiff. Paste to paste mix. Auto mixing, handheld. You can held it with the hand also. And mechanical, you have, if you want to use, you can use the mechanical dispenser, which is of which leads to high viscosity. Advantages: it is highly accurate as that of addition silicone. Good dimension stability as that, same as that of addition silicone. Stock or the custom trays are used. Good surface details. Pour within 1 week, but you have to keep the impression dry. You can pour the multiple cast. Good wettability, same as that of your addition silicone. Disadvantage: it is expensive, short working time, it is rigid, difficult to remove from the undercuts, bitter in taste, it has the low tear strength, absorbs water and change the dimensions when water get absorbed in the material. So some MCQs from the polyether. So hypersensitivity reactions like contact dermatitis can caused by polyether. It is your question which is asked in your EIPG, that due to its bitter taste, it can cause the hypersensitivity reaction like contact dermatitis. So polyether has the least shelf life. Polyether has the least shelf life. This question is being asked in AIMS. So now we have discussed the alginate, the polysulfide, the silicones, condensation silicon, addition silicon, polyether. Now comes the topic agar, which is aqueous hydrocolloid and irreversible in nature. It is reversible hydrocolloid. Indication: it is used in the crown and the bridge. It is highly accurate. Example is slate hydrocolloid by Van R. Very important, like your alginate composition. Agar. It has a complex polysaccharide. It is obtained. Agar is obtained from the seaweed. It itself acts as an MCQ. Agar is obtained by seaweed. It has the gelling agent. It contains borax, which provides strength. It contains potassium sulfate, which improves the gypsum surface, and it contains water of about 85%. So why it is known as reversible? Because your solution get converted into gel, and your gel is simultaneously converted into solution, vice versa. So agar hydrocolloid, when it is hot, you cool it down to 43 degrees Celsius, it get converted into agar hydrocolloid cool. When the agar hydrocolloid cool, it's heated to 100 degrees Celsius, it get converted into solution. That is agar hydrocolloid. I repeat, when the agar hydrocolloid or the solution, the hot solution get cooled to 43 degrees Celsius, it leads to agar hydrocolloid and converted into gel form. When the gel form is heated to 100 degrees Celsius, it get converted into solution. Manipulation: gel in tubes, syringe and the tray material. Manipulation: this consists of 3-chamber conditioning unit. First, liquefies at 100 degrees Celsius for 10 minutes. It leads to conversion of the gel form to solution form. Second is it stores at 65 degrees Celsius and then place the tray. And third is temper at 46 degrees Celsius for 3 minutes. Seat the tray, cool with the water at 13 degrees Celsius for 3 minutes. It gets converts into solution to gel. When you liquefy it at 100 degrees Celsius, it gets converts into gel to solution. When you cool it down, it gets converts from solution to gel. Now this is a term which is known as temper. What is temper? Tempering is a term which is used when you heat a material to a high temperature, though below its melting point. You have kept the temperature below the melting point and then cool it down either with the usual air. It is known as tempering. I repeat, when you heat any material to a high temperature but below the melting point and then allow the material to cool in the usual air, it is known as tempering. Same way, when you boil this in the when you liquefy this in the 100 degrees Celsius, you get temper to 46 degrees Celsius for 3 minutes. You see the tray, cool with the water to 13 degrees Celsius for 3 minutes. Then your solution get converts to gel form. Advantages: it is dimensionally accurate, hydrophilic, means it absorbs water, displaces moisture, blood and fluid as same than that of alginate. It is inexpensive after initial equipment. No custom trays or adhesives are required. Pleasant flavor, no mixing required. Disadvantages: initial expense, special equipment required. Material must be prepared in advance. Tears easily, so dimensionally unstable, leads to tearing. Must be poured immediately. Can be used for a single cast. You can pour a single cast, not a multiple cast from this. Difficult to disinfect as same than that of alginate. So I have some MCQs of agar also, which has been already been asked in your AIPG exams. So best material for duplicating the cast is agar. It is being asked in your AIPG exam. Agar syringe material can be used with the agar and the alginate impression material. I repeat, agar syringe material can be used both with the agar and the alginate impression material. Brush heap structure. You can see the brush heap structure in an agar. This question is frequently asked by AIMS and by your AIPG. I repeat, the brush heap structure is seen in agar. So basically agar requires a hardener to set. This is asked in AIPG. So these are the handling properties of various impression materials. Starting with the handling properties: agar, alginate, polysulfide, condensation silicon, adhesion silicon, and polyether. Starting with the preparation, you have to boil, you have to temper. Boil and then allow. What is temper? I have already told you that heating a metal in a high temperature but below the melting point, then cool that material in an air. It is known as temper. So you have to boil, the temper, and then store. Alginate, you have to mix the powder with the water. Polysulfide comes in the toothpaste, you have to mix the toothpaste. Condensation silicon come with the toothpaste or paste or liquor, you have to mix either the toothpaste or the paste with the liquid. Adhesion silicon come with the toothpaste, you have to mix the toothpaste. And polyether, again you have to mix the toothpaste. Ease of use. It is technique sensitive. It is easy to use. It is fair to use. It is fair, ease of use, excellent to use, and good to use. Patient reaction. Patient may experience a thermal shock in agar. Patient may experience a pleasant and a clean reaction. You can see a pleasant and a clean reaction when you are using an alginate. Same way you can see the patient with the when you're using condensation silicon, pleasant and clean, and in the polysulfides and the polyether it contains unpleasant and cause the stains. Polyether causes, I have already told you, polyether causes the hypersensitivity reaction, the contact dermatitis. Ease of removal. It is very easy to remove. Alginate is very easy to remove. Polysulfide is easy to remove. And condensation silicon is moderate to remove. Adhesion silicon, moderate to difficult to remove the polyether. Disinfection. It has the poor disinfection. It also has the poor disinfection. Can't disinfect. It has the fair property. Condensation silicon has the fair property. Adhesion silicon has the very good disinfection property. And polyether is also having the fair disinfection property. See, this chart is very important from your exam point of view. Every point itself acts as an MCQ, so you have to be thorough with this table. So coming on to the working time, agar takes 7 to 15 minutes of the working time, alginate takes 2.5 minutes, polysulfide takes 5 to 7 minutes, condensation silicon takes 3 minutes, adhesion silicon takes 2 to 4.5 minutes, polyether takes 2.5 minutes. Setting time of the agar is 5 minutes, of the alginate is 3.5 minutes, polysulfide 8 to 12 minutes, condensation silicon 6 to 8 minutes, adhesion silicon 3 to 7 minutes, polyether 4.5 minutes. According to stability, it takes 1 hour with 100% of relative humidity. you have to pour immediately. Polysulfide, you have to pour within 1 hour. Condensation silicon, you have to pour immediately. Addition silicon, you have to pour within 1 week. And polyether, you have to pour within 1 week, but you have to keep the impression dry. Wettability and castability, it has the excellent wettability and castability. Alginate is also having the wettability and castability because these are hydrophilic in nature. And polysulfide and condensation silicon, they have the fair wettability and castability. And addition silicon is fair to good. Polyether has the good wettability. Cost, agar is of low cost. Alginate is very low. Polysulfide is low cost. Condensation silicon is moderate. Addition silicon is high to very high, and polyether is very high because these two produce accurate details and has the good dimensional stability. So their price, their cost is very high. I hope this table is clear and you have to be thorough with this table. Coming on to the properties. Elastic recovery with the percent 98% of the agar, alginate 97.3, polysulfide 94.5 to 96.9 of the elastic recovery. Condensation silicon ranges from 98.2 to 99.6, addition silicon 99 to 99.9%, polyether 98.3 to 99%. Flexibility 11% of the agar, alginate constitute 12% of the flexibility, polysulfide constitute 8.5 to 20% of the flexibility, condensation silicon constitute 3.5 to 7.8%, addition silicon constitute 1.3 to 5.6, polyether constitute 1.9 to 3.3%. Flow, it is negligible. Polysulfide 0.4 to 1.9%, condensation is less than 10%, addition silicon is 0.5%, and polyether is also 0.05%. Shrinkage within 24 hours, extreme shrinkage. So you have to pour the cast immediately in agar and alginate. Shrinkage within 24 hours in polysulfide leads to 0.4 to 0.5%. In condensation silicon, it leads to 0.2 to 1%. In addition silicon, 0.1, 0.001 to 0.2, and in polyether 0.2 to 0.3%. TS strength 700 gram centimeter of agar, alginate contribute to 380 to 700, polysulfide 2240 to 7410. Condensation silicon have the TS strength of 2280 to 4370. Addition silicons constitute 1640 to 5260, and polyether constitute the TS strength of 1700 to 4800. So see the comparison of the property. These 2 to 3 slides I have specially put these slides in the last because these are itself it as an MCQs, a number of questions being asked in the AIPG and your AIMS exam, number of questions according to working time, according to settings time. So you can expect at least one question from these comparison of properties. Starting with the working time, longest to shortest. It contains agar, then polysulfide, silicons, alginate equal to polyether. According to setting time, shortest to longest. Alginate, then polyether, agar, silicons, and polysulfide. Please make it clear that you have to be thorough with these slides. I have specially prepared these slides and put into the in this impression material topic because number of questions means repeatedly being asked from this topic. So stiffness, according to stiffness, most to least. Polyether, then addition silicons, then condensation silicons, then polysulfide equals to hydrocolloids. TS strength, greatest to least. polysulfide, adhesion silicon, polyether, condensation silicon, hydrocolloids. You have to mug it up. According to cost lowest to highest. As you know, alginate cost the very low. Alginate, agar, polysulfide, condensation silicon, adhesion silicon, and polyether. Polyether is very expensive. Dimension stability best to worst: adhesion silicon, polyether, polysulfide, condensation silicon, and hydrocolloid. Comparison of properties according to wettability best to worst: hydrocolloids, polyethers, hydrophilic adhesional silicon, polysulfide, hydrophobic adhesion silicon, condensation silicon. Hydrophilic which contains water, hydrophilic which retains water, which contains water. You can say imbibition, hydrophobic which you can say shrinkage, or which you can say syneresis. It gains hydrophilic, it gains water, it loses the water, it lost the water. According to castability best to worst: hydrocolloids, hydrophilic adhesion silicons, polyether, polysulfides, hydrophobic adhesion silicons, condensation silicons. So these are the comparative properties of the elastomers. Only elastomers: polysulfides, condensation silicon, adhesion silicon, polyether. According to flow, it has the high flow, polysulfide has the high flow, condensation silicon have the low flow, adhesion silicons very low flow, and polyether also very low flow. Viscosity: according to viscosity, it has the low, polysulfides has the low viscosity, condensation silicon is the moderate viscosity, adhesion silicon and the polyether with the high viscosity. Creep: with the high, polysulfides has the high creep, condensation silicon with the moderate creep, adhesion silicon with the low creep, and polyether with the very low creep. TS strength, please, it's very important point. TS strength: polysulfides have the 2500 to 7000 of the TS strength. Condensation silicon constitutes 2300 to 2600 of the TS strength, and adhesion silicon ranges from 1500 to 4300 of the TS strength, and polyether ranges from 1800 to 4800 of the TS strength. Shelf life: polysulfides have the fair shelf life, condensation silicon have the poor shelf life, adhesion silicon have the excellent shelf life, and your polyethers have the fair shelf life. Setting time: 8 to 12 minutes of the polysulfide. Condensation silicon has the 6 to 8 minutes of the setting time, and adhesion silicon constitute 4 to 7 minutes of the setting time, and 3 to 5 minutes ranges from 3 to 5 minutes of polyether. So working time: 4 to 7 minutes of your polysulfide, 2.5 to 4 minutes of condensation silicon, 2 to 4 minutes of adhesion silicon, and 3 minutes of polyether. Stiffness: polysulfides has the low stiffness, condensation silicon has the medium stiffness, adhesion silicon has the high stiffness, and polyether constitutes a very high stiffness. So these are the problem solving. It is divided into visible flaws, which is visible, and something related to another is invisible flaws, which we can't see. So visible flaws related to impression technique, which occur commonly, which includes the finish line not visible, air bubbles in the critical places, voids or drags, unset impression materials. Unset impression materials on the surface of impression and the cast. These are the invisible impression flaws which we can't see, resulting in an apparently good fit of the restoration on the die but a poor fit on the tooth may also occur because of trace and the impression recoil, detachment of impression from the tray, permanent deformation. Visible flaws includes the finish line not visible, gingival inflammation and bleeding, subgingival finish line, localized gingival overgrowth, retraction cord displaced from the sulcus. The visible flaws can only be related to your gingiva. For example, your gingival inflammation, your subgingival finish line, your localized gingival overgrowth, and when you place the retraction cord, it can be displaced from the sulcus. So air bubbles in the critical phases, you can also see the voids and unset impression material. Invisible flaws, impression and the tray recoil, detachment of impression from the tray, permanent deformation, the problem of recording multiple preparations. So this is all about the impression materials. Now coming on to the MCQs which is being asked. I have already told you a number of MCQs of alginate, of polysulfides, condensation silicons, additional silicons, polyethers, and your agar. And apart from these are some of the MCQs. I have specially put these slides for you guys so that you can prepare these kind of questions may come in your entrance examination. So all of the following can be used to slow down the setting of the zinc oxide eugenol impression paste, except altering the amount of the toothpaste used, adding a small amount of water, adding a small amount of glycerin, cooling the mixing slab. Now I have put these questions. Now you have to answer these questions. So the answer is adding a small amount of water. I have already discussed this with you. Type 1 and type 2 zinc oxide impression paste differ with respect to water content, their hardness after setting eugenol content, or their use. Answer is their hardness after setting. Hysteresis is a hydrocolloid gel. Is phenomena of conversion of gel into solution, temperature lag between gelation and liquefaction temperature, moisture absorption, or all of the above. The answer is B. Temperature lag between gelation and liquefaction temperature. The term given to the phenomena of moisture absorption by the alginate impression is hysteresis, imbibition, synergesis, gelation. You know it's imbibition. I have told you several times. The base paste of the condensation polysilicon has a low molecular weight dimethyl silicooxane with a terminal group, silane group, hydroxyl group, vinyl group, mercaptan group. Answer is hydroxyl group. The impression with the least dimensional change upon disinfection is agar-agar, polysulfide, polyether, addition silicon. It is addition polysilicon. Best material for duplicating cast. I have told you. Best material for duplicating cast is alginate, Paris of plaster, zinc oxide eugenol, or agar-agar. Think. It's agar-agar. I have told you. Palladium. Palladium is added to polyvinyl silicon to it acts as a plasticizer, catalyst, scavenger and surfactant. Guys, I've told you it is scavenger. So syneresis. Syneresis is what? It is seen as the water loss or shrinkage or water loss. So imbibition, which swells up or gain water, swells up, and syneresis is water loss. Impression techniques are used for recording oral mucosal tissues or dental hard tissue, oral mucosal tissue, or none of above. It's oral mucosal tissue and dental hard tissue. Guys, what you have to do is you just go through these questions. These are very important for your exam point of view. I have specially put these questions for you guys. The impression material used to record the prepared areas on the abutment teeth is low viscosity elastomeric impression material, medium viscosity elastomeric impression material, high viscosity elastomeric impression material, or none of above. It's low viscosity impression material, elastomeric impression material. Syringe material is medium viscosity, low viscosity, medium, low viscosity elastomer, high viscosity elastomer. Answer is low viscosity elastomer. Solution to gel transfer formation is seen in hydrocolloids. The best constituent of reversible hydrocolloid impression material is alginate, alginic acid, agar, or gelatin. It is agar because it is a reversible hydrocolloid, not irreversible. Agar syringe material can be used as alginate impression material, agar, both. I have told you it is used in the both of the above. Alginate impression material also and in agar also. Tear strength for the impression material is highest for polysulfide, adhesion silicon, alginate, or condensation silicon. It is in the polysulfide. Which one of the following final impression material should not be used in the patient with a dry mouth? Zinc oxide eugenol, alginate, Paris of plaster, or polyether? Very important question. It's zinc oxide eugenol. Which of the following material setting is inhibited by latex gloves? Polysulfide, adhesion silicon, condensation silicon, or polyether? I've told you it's adhesion silicon. So which of the following is the byproduct of the condensation silicon? Ethyl alcohol, water, hydrogen, or CO2? It's ethyl alcohol. Which of the following is the catalyst in the condensation silicon rubber? Orthoethyl silicate, polydimethyl silicoxane, stannous octate, or colloidal silica? It is stannous octate. I have shown you in the reaction also. Which one of the following impression material cannot be used for making primary impression for the edentulous arch? Alginate, impression compound, silicon monophase, silicon putty? It's silicon monophase. Agar is prepared from seaweeds. So thank you so much. I hope it is clear to you. Please go through the slides. Please go through this impression material. I hope 2 to 3 or not even 2 to 3, 1 to 2 or 2 to 3 questions may come in your examination. So you should be thorough with the slide. Thank you so much.